tend not to use, but there are times in certain parts of the world where this is all you're going to be able to get, and unquestionably this is better than using cement. That's what you'd say, really. The thing to do with this, if you were going to use it for building, would be to do what we've done there and add it to water and make a paste out of it about 24 to 48 hours before you use it, and that tends to make it a bit fatter and a bit stickier than otherwise. But and the other crucial thing is, if you have to use hydrated lime, is that you use it as fresh as possible.
Did Stafford explain to you what the difference, what hydrated means as opposed to hydraulic and so on? Yeah.
Yeah. So this is hydrated lime, and then this here is hydraulic lime. So this is hydrated hydraulic lime, but a different material. So are people clear about this? This is a lime that is burned just the same way, well, but more industrially, typically these days, but which contains a proportion of clay, so that when it's fired, that clay becomes an active chemical ingredient in effect. So that when you make a mortar with this lime, you'll get two sets happen. You'll get, this will only set by carbonation, so by taking carbon dioxide from the atmosphere whilst it's moist. That's crucial. It won't do it when it's dry. The same with putty lime, the same with quicklime. That's how they set, and that needs to be a slow set. Drying is not the same as curing in the case of these mortars or any lime mortars. They need to cure at a steady rate for a period of time, whether it's 4, 5 or 10 days, or depending on the lime. Not just dry as soon as they can, because they'll be weak and they won't be carbonated. A hydraulic lime like this has an initial chemical set, as cement does, driven by the same ingredients, the same chemical ingredients in effect, as cement has in it. That's only part of the process. There is then a subsequent carbonation set, because typically this is an NHL 3.5, but typically this is about 40% lime that has these active ingredients in it, and about 60% free lime, which is in effect just hydrated lime content. So that needs to set by carbonation. So you get the initial set, and then you get the carbonation set. So that's important to remember, and that's what distinguishes a hydraulic lime. The other thing that distinguishes, of course, is that it sets much harder and more densely, usually, than a high calcium lime, which is a putty lime or a quick lime. And the grades. And I think Stafford's talked about that as well, the grades of 2, 3.5, 5, if people are clear on that. What it's important to say is that certainly in this country, there is no historic lime mortar that was ever as hard as NHL5, for instance. So what we called an eminently hydraulic lime is 3.5, or is the equivalent to 3.5. So that was the sort of line they were using for most, where they use hydraulic limes in this country, for concrete, for really hard wearing things. It's very common, and most lime suppliers will fall into the trap of making equivalent these categories of feebly, moderately and eminently hydraulic, and think that equates to 2, 3.5 and 5. It simply doesn't. Certainly in the context of our geology anyway, it doesn't. So the hardest line we tend ever to use is 3.5 ourselves. Most of our work these days, certainly the last 2 or 3 years, most of our work we do with just quicklime. So pointing, all that sort of thing, bedding, and we mix that lime hot. So we're going to do some of that today. So the lime revival that we're part of